Now let's just take everything that we just learned and kind of apply it, all those exponent rules. So let's say I have 3x squared times 5x. You do the constants, then you do the variables. So 3 times 5 is 15. X squared times x is x to the 2 plus 1, which is that. Cool. What about, okay, well that's 9 divided by 3, which is 3, and then x squared divided by x, which is x to the 2 minus 1, which is x. Would you say then that 9x squared is actually a perfect square? Yeah, looks like it. I didn't even plan that. We know and love dearly the distributive property. As a reminder, if we have anything multiplied by some addition, we kind of multiply that outside thing by each of the things on the inside, and then keep the plus. So you have A times B plus A times C. 5x times x squared plus x plus 2, let's say. It doesn't matter how many extra things we're adding up on the inside like this. We still distribute the outside factor to each different term on the inside. So this would be 5x times x squared, x to the third, plus 5x times x, well that's just 5x squared, and then 2, 5x times 2, so that's 10x. 3, I'm just coming up with random things. 3x squared y times 7 cubed plus, so let's distribute. When we got a lot of different exponents with multiple different variables and constants, just do it one like kind of thing at a time. And by kind of thing, I mean whether it's a constant or a variable or a second different type of variable or a third different type of variable, or if I can even speak. So 3 times 7 is 20. Let's just do them one at a time. 3 times 7 is 21. X squared, well, there's no other x's, so that's just x squared. And then y times y cubed is y to the 4th. Plus, again, do it, what do my notes say? After the constants, do them one variable at a time. So the constants, 3 times 12 is 36. Yeah. X squared times x is just x cubed. And then y times y is y squared. What if I want to distribute a negative? Not even distribute something with the negative on the outside. What if I just want negative x plus 5? Well, a negative on the outside of that, as it's stated here, is assumed to be the same thing as, well, any other negative is going to be assumed to be multiplied by -1. That's what we are kind of assuming here, is a negative on the outside is the same thing as a coefficient, if you will, of -1. So we would then distribute -1 across this, which would get us -1 times x, which is -x. -1 times 5 is -5. So -x minus 5. And it's easy to see that if we had negative, I don't know, z minus 2, distributing the negative would be negative z negative -2 or +2.